Okay, significant figures in calculations. We're talking about adding, subtracting, multiplying, and dividing, and keeping your significant figures correct. If you have not already done so, I have a video on significant figures so that you can identify how many significant figures there are in a number. And I suggest I'm kind of taking a little assumption that you already understand that. The next thing is we're going to do some calculations. This will go a lot better if you pause the video right now and get yourself a calculator. Get a calculator and work through the things with me, and it'll make a lot more sense. So by the end of this video, you will understand why 4 centimeters times 3 centimeters is actually 10 centimeters squared. Let's get rolling. The rules for adding and subtracting. You limit the reported answer to the rightmost column that has all the significant figures in common. Let me give you an example, and this will make more sense. If we were going to add 83.26 grams to 24.9 grams, what I mean by the rightmost column is this first number, its significant figures go to the hundredths place. But the second number, the significant figures go to the tenths place. This second number is not as precise. It's not as significant as the first number. The 24.9 is not as precise. Therefore, when you're reporting your answer, you can only report it as the weakest measurement. Think about like the analogy of a chain. A chain is only as strong as its weakest link. Well, calculations in science are only as strong as your weakest measurement. So because of this, well, first of all, if you put this in your calculator will say 108.16, which is acceptable. That is the answer in your calculator. But when we report this, we can't report it to the hundredths place, again, because we don't really know what this value was. It wasn't measured, so we shouldn't report that. So the rightmost column that has the same significant figures in common is the tenths place. So if we kind of draw a line here, this shows where we're going to cut off our measurement. So we're only going to measure up to the tenths place. Because if this is a 5 or greater, it will round this number up. So after the 1 here, if this was 5 or greater, which is a 6, so we're going to round it up. So we're going to report the number as 108.2 grams. If this was a 0 to 4, we would just have left the 1 alone. When multiplying and dividing, count the number of significant figures in each number being multiplied or divided, and then limit the significant figures in the answer to the lowest count. Let's give this an example here. If we're going to multiply 38.65 meters times 105.93 meters in your calculator, and I suggest you actually do this for yourself, you should get a very large number. You get 4,094.1945 meters squared. Again, when you're multiplying units, if they'll combine and you make it squared. When you're dividing units and they're the same unit, they remove from each other. You cancel them out. Anyways, you get this very large number. But it says count the number of significant figures in each number being multiplied. So in the first number, we've got 4 significant figures. And in the second number, we've got 5 significant figures. Limit the significant figures in your answer to the lowest count. So our lowest count is the one with 4 significant figures. So our answer should only have 4 significant figures, not 1, 2, 3, 4, 5, 6, 7, 8. This is much too precise of an answer for what was actually measured. We cannot answer with more precision than we actually measured in lab. So what we measured was these values. So our answer should reflect that. So to answer this with 4 significant figures, 1, 2, 3, 4, we just go with 4 and we stop. Basically, significant figures in calculations is rounding off and knowing when to round off for the most part. Let's go through some examples with multiplying, dividing, adding, and subtracting now. Again, get a calculator, plug this in, and verify for yourself. So when you take 550 liters minus 27.4 liters, what do you get? Remember, when you're adding and subtracting, you can only add and subtract values that are the same. In other words, if you've got apples and oranges, if you have a bunch of oranges, you can't say subtract 2 apples from it. There are no apples. You have to have the same unit to add and subtract. So we take these two values and we subtract them, and we're going to then look at the value where the significance stops. Remember, trailing zeros only count if there's a decimal place. So this only has 2 significant figures, while this one has 3. But regardless, this goes to the tenths, while this, goes to the 10 place, while the following number only goes to the tenths place. So we're going to go here, and we're going to have to round off at this point here. Because the number after 522, this 2 is 5 or less than 5, we don't have to round up. So we would record this as 520 liters. Try this one. 1.8 liters divided by 36 seconds. Now, when we're multiplying and dividing, you can use different units, but if these were the same units when you're dividing, they would cancel each other out. These are different, so they're just going to stay liters per second. This would be like flow, how a fluid going through a certain rate. So this is liters per second would be like a measurement of flow. Anyways, put this in your calculator, and you get 0.05. Now, when you're multiplying and dividing, you limit your answer to the least significant figures. The first number has 3 significant figures. The bottom, the denominator, has 2 significant figures. Our answer, remember, leading zeros, these are zeros in front of a number, never count. So the answer actually only has 1 significant figure, but we need to have our answer with 2 significant figures. So we would add a 0. Trailing zeros count if there's a decimal place. So this number has 2 significant figures. These are your 2 significant figures. And don't forget your units. We have liters per second, so leave it liters per second. In your third example, multiply these two together. You get 12.5 centimeters times 10.4 centimeters. If you're multiplying the same unit, they combine, and you would put squared. If there was 3 of them, you put cubed. If they were different units, you would just keep them together. You wouldn't cancel them out. Anyways, you put this in your calculator, and your calculator says 130 centimeters squared. Well, we've got 3 significant figures here, 3 significant figures here, but your calculator actually gave you an answer with only 2 significant figures. We need this 0 to count. We need the reader to understand that this 0 is significant. So, trailing zeros count if you put a decimal place. This number has 2 significant figures, but this number has 3 significant figures. So this would be the proper way to record this answer. Let's add these 2 values together. And when you're adding and subtracting, we're going to go to the column that has the significant figures in common with each other. So when we put these 2 together, they actually go to the same column together. However, 8 plus 2 is 0, and then we would carry the 1, and then we got 1 plus 2 plus 7 is 0. And when you put this in your calculator is going to say this for an answer. However, these 2 columns are important, so when you record this, you got to add those zeros here to show the significance. So the proper way to record this answer would be 0.030600. You got to put those zeros there even though your calculator did not. So you got to pay attention and report the significance that your measurements actually had. Our final example is going to be a word problem. Kevin has 4 bowling balls which weigh 23.0 kilograms together. What is the average mass of 1 bowling ball? So to do that, we would say 23 kilograms divided by 4 bowling balls, and you come up with this answer here, 5.75 kilograms per ball. Remember, the kilograms and balls don't cancel out. Now, you might be tempted to say, okay, well, we've got 3 significant figures in the kilograms, in the mass, and we've got 1 significant figure in the amount of balls. Just remember that bowling balls is an exact number in this situation. When you're counting is an exact number. You can't count. You could measure the mass better. You could say it's 23.0 kilograms, and you could get a more precise instrument. You could say it's 23.02 kilograms. You can get a more precise instrument and get more significant figures in this mass. However, you cannot get more significant figures when you're counting. There's 4 bowling balls. Well, okay, go back and do it again. Do it better. Be more careful this time. How many bowling balls are there? There's 4. There's nothing you can do about that. So when you're using exact numbers, exact numbers do not limit your answer in calculations. So since there's 3 significant figures here, we're going to answer with 3 significant figures. Here's some extra examples. I'd say pause the video, do these. They're not difficult. You just do it in your calculator, but the trick is knowing how to report those answers. So pause the video, try these, and you can go to the website and print this out as well. And then try these rest of these. Again, pause the video, give these a try. If you have any questions, please contact me. I'd love to help you. I want to see you successful in this. Being able to calculate properly with significant figures in science is crucial. This is a foundation that's going to be with you throughout your career in science. So, get good at this. It will be important. And I will talk to you later.